All right, let's see here. This goes there, that goes that. All right, I think we're all set. Let me just see this thing. All right. Hopefully the audio level's fine. What's up, Drac? How you doing, buddy? Oh, I forgot to change my title. Excuse me. Sorry, I was sneezing. I'm just over here sneezing. I'm also working. No, we're gonna do a programming language Monday today. I did finish the book, Crafting Interpreters, though. You need unit assist to bring back Jomi and the others. See, the problem was that I introduced them. Now they don't want to watch me anymore because they know there's just better content out there. They just know. It has been a while since I've seen. Everyone pops in every once in a while. I think people are just busy, which I can understand. I can appreciate it. Yeah, they're probably watching pool streamers, hot tub streamers. That's probably where Conifer went to. He abandoned us. Are you still learning Go? Mess around with web API stuff? Oh. What's up, Samuel? I was wondering how you recommend starting with Go coming from a high-level language like JavaScript. I guess it depends on what you're trying to do, but the big difference between Go and something like JavaScript is that JavaScript's dynamically typed, where Go is statically typed. So you kind of have to keep in mind that you need to declare all of your types beforehand. But yeah, other than that, I don't think it's going to be that big of a jump. I think the package management stuff is way simpler in Go than JavaScript was, like NPM. But there's what's it called? Go by example, which is this website, which will teach you a lot of important stuff for it looks mostly, it goes a very back-end focused language, right? But if you check this out, this is a pretty good thing. But it's basically just a bunch of examples of how you do different stuff. So assuming you know programming languages in general, this is a good tutorial, I think. Yeah, other than that, I always recommend people have like a project in mind of what they're doing and then learn what you need to learn to solve that problem. But Go is a pretty simple language, so you can learn it pretty quickly. You could even read the documentation. It would probably take you like an hour. But so Go is a pretty simple language. Compared to JavaScript, Go is very, very simple. I don't even know if I consider JavaScript that much more higher level than something like Go. Like Go is pretty up there. Other than the dynamic versus static typing. Oh no, C. Yeah. Back to C lang. Yeah, I think a lot of the reasons why C is difficult is because you have to manually manage your memory. And Go doesn't have that at all. Go's garbage collected, like JavaScript's garbage collected. Other than that, like you basically just have to define your types. Like you'll have these type declarations which say what every type is, and then you can't really change that. Whereas in JavaScript, you can just be like, oh, I want to add a field. I want to add this like new piece of data to this thing. You can emulate that stuff with hash maps in Go, but you can't just like throw methods and fields on things. You've got to be like very precise about what you're doing. Which I think is in general a good way to program, but I know some people don't like it. Yeah, if you use TypeScript, then you'll be if you're familiar with TypeScript, it's like similar to that. TypeScript's probably more expressive and more complicated than Go, though. Like some stuff you might want to do that you might do in TypeScript, you won't be able to do in Go. But that's just from what I've seen from TypeScript snippets. I've never really used TypeScript. So yeah. Yeah, I recommend Go. I think it's a pretty quick learn, I think, compared to a lot of other languages. Like a lot of languages come with like a book these days. I was also checking out like look at this stuff. Like this is Rust, right? Like this massive book you're reading with like big chunks of like text and stuff. And then I was looking at Jai, and this is like the Jai book. It's like, do we really need it? Like, I think I don't know, my opinion is that like, if your language is that complicated, I get it. I get that there's more complicated languages, but I just feel like people need to make simpler stuff. What's up, Lulu? Is this pre-recorded live? No, this is just live. Live recorded live. Live recorded live. Want that. There's also this token type that I want. I want the scanner. I finished the whole crafting interpreters book, so I'm kind of what I want to do now is I want to use his same exact pattern, but build a Go-like interface. And I want to just make like a really, really low level layer on top of C. Where's my thing? There it is. Like I want like C, every feature in C. I just want to build like a better syntax on top of it. Like that's kind of my objective at this point right now. I am new to this. Can you tell me what language I should go to first? It depends on what you want to do, I think. Do you have any ideas of what you want to be building? If you tell me that, I can give you a recommendation. Like you want to build games, you want to build websites, you want to build what? All right, there's our tokens. I'm just kind of copying stuff from this other code that I wrote when I was doing that book, Crafting Interpreters. So I was looking for some low-level language for game dev, and that's how I found your channel. It seemed very cool what you're doing with Mythball. Yeah, if you want to make a game, I don't know if I'd really recommend, I guess, if you want to make a game in Go, you should use Ebit Engine. Go is a simple language though, which means that you don't get as much expressiveness as you get from more advanced languages. So there's pros and cons to that. But if you're making a simple enough game, then yeah, if you're making a simple enough game, then Go will definitely do what you need to do. But as soon as you're, like if you're not making a really, really complicated game, I don't know if I'd recommend Go anymore. I'm not building anything, I want to learn for fun. I'm alone all the time, so I want to keep myself busy. Okay. Let me think. I mean, I might just... I'm just trying to think of like... It's just hard because some languages are just very suited for certain things. If you just want to learn programming though, you might just start with C. C is like hard mode programming. So like B-Flang. If you learn C, you'll learn about how computers work. So like, I think that that's a huge advantage. Whereas if you start with a high level language, you're not really going to learn how computers work as much. But if you want to learn, this might be a little bit too advanced if you're just starting. Yeah, it probably would be. I was going to suggest that Crafting Interpreters book, but I think that would be too tricky for a brand new programmer. But yeah, I mean, if you want to do games, you could just download Unity and then like start making video games and stuff like that. Or if you want to do languages, there's this book. This is the book I was talking about. But that might be a tough starting spot. But maybe C. And just start with C. Don't do C++. Not that there's anything wrong with C++. It's just a lot more complicated of a language. But C++ has some niceisms to it too. So, but I don't know. Like C is as simple as it gets, pretty much. C is as low level as most people would ever program in. What's making you change on Go? There's just a few like compile time things that I want to be able to do that I can't really do in Go. I mean, like it's all the normal stuff, right? It's like garbage collector gets in the way. What else? Like having to use interfaces everywhere instead of like a tagged union kind of kills me sometimes. So I can't really represent like what I want in the data that I want it to be. I end up having to like make these arbitrary interfaces just to like polymorphize multiple types into one list or something, you know? So you end up with like a bunch of like stupid stuff you do just to work around the type system. So I just think Go is good for simple things, or very well structured things. But like, man, if Go had like union types or enum types or whatever you want to call it, and then a little bit of manual memory management, a little bit less runtime crap, it would be great, I think. How long have you been coding? 10 plus years. I don't know the exact number. I started C++ for fun, but 1 week and the learning curve is super steep. I'm thinking if it's worth it. I'm still thinking if it's worth it to commit to it or not. Yeah, the problem with C++ is it comes with a lot of like, it comes with a lot of baggage of how C++ wants you to write code that doesn't really encapsulate like what computers do. So you end up building like classes, and you end up building constructors and destructors, and like you do all of this stuff. And for a new person, I don't think it's very clear like why you're doing it. So it's like, oh yeah, we build classes in C++, and like here's a constructor for the class. And it's like, okay, like I don't know why we have to do this. So I think it's better to like learn the whys of how you want to structure your code. And I think starting with a simple procedural language like C is pretty good. C, the problem with C is that it's very verbose, and there's a lot of like weird things in it that you have to deal with. Like that's pretty much the only downside with C, I think, as like a learning language, in my opinion. This is gonna sound cliche, but I think you'd love Rust if you got deep into it because of the increased level of control. Rust is just too big of a language for me, I think. And I don't know. I guess I don't know enough Rust to like really give a super well-formed opinion. But like Rust was just like Rust was too much guardrails for me, I think. My goal is to just learn low level, but Rust was definitely an option, but me people point to C before Rust. Yeah, Rust will teach you a little bit about how computers work, I think. But in Rust, it's more like you have to appease I almost said garbage collector. You have to appease the borrow checker. So you're not really like, and then the borrow checker is gonna like do all the memory management for you. It's just about like what you want to learn. It's hard when you don't know what you want to build. If you know what you want to build, then like I can give you a pretty concise recommendation. But if it's like, I just want to learn programming, then it doesn't really matter. You can pick any language and just do it. Thought that as first, but I work with a bit more typical things. Instead of game dev, I just clicked and made more sense. Yeah, I mean, for Rust, you pretty much have to use Bevy. Or sorry, there's other ECSs, I guess, but you end up using an engine in Rust for game dev. But like, there's just a few things that like were painful right off the bat, and I just didn't really want to deal with it. The syntax is very terse. The number of the different string types was confusing to me. Like, at least when I see string types in like Zig, I like kind of know what they are. I just couldn't like, I don't know. It's just like everything's abstracted too far for me, I guess. Maybe I just didn't do enough with Rust. I don't know. The project has improved a lot in 2 years though. It's a very different experience than when you last tried it, I think. Oh, really? That's cool. Yeah, there was quite a few times where I'd be like, man, there's no possible way that this pointer can alias. Like, I don't know why why I like can't figure this out statically. So you have to do like a lot of weird stuff. So maybe those are fixed now. I don't know. I don't think it's necessarily a bad idea to have some kind of like reinforcement to protect your memory like that. I don't know. I'm kind of interested with like arena allocation strategies and stuff. Why do you think you wouldn't use C in the future? Lua? Oh yeah, people recommend Lua a lot too. You might try that one. I've done a little bit of Lua. Come to the dark side, Rust. C is just an old language, and there's just in my opinion, there's just like when people were starting to write C, there wasn't very much knowledge about programming languages. Now there's a lot of knowledge about them. So there's like a lot of very small incremental improvements you can build on top of C that are super obvious, but C can't add it because of backwards compatibility, I guess. Like C is a fine language, but like there's just little things like at the end of case statements, you have to put this word break, like arbitrary, or not arbitrarily, but like the default was just the wrong one. It's better if it just, there's no break statement, because most of the time you want to break. You don't want to fall through. Or you have to manually hoist all your function declarations to the top. Like the compiler won't figure that out for you. Or like when you're declaring types. Where is it? You can't like recursively define a type. And you have to like do these weird type def things for your types, which isn't that bad, I guess, but yeah, if you're doing game dev, you want to use something. You don't want to build a renderer probably if you're just starting out. There's just a lot of weird things in C that you have to deal with. A lot of missing like expression problems. You can't do methods. You can't, there's a lot of stuff. But some people like that stuff, so they stick with C. Or it's like what they're used to, so they stick with C, Make. Okay. But yeah, I think don't get into the situation where you're just like constantly, should I do this or this? And like, what's it called? This like decision anxiety that people get. Because it's not that important what you start with. So just pick something that kind of fits what you want to do. Do it for a bit and then do something different. I think go wide when you're just starting out. It's better to go wide than it is to, what is your programming language name? I don't have a name for it. I'm just kind of messing around. I just finished the Crafting Interpreters book, so I'm kind of experimenting a little bit still. I think Golang's a great choice for learning programming because it exposes you both to low level and high level aspect of programming, lets you kind of dip your toes in any of the areas. Yeah, that's probably true. It's also a simple language, so there's some advantages with that. Okay. Compile. This is where we have to do the parsing stuff. Sorry, I'm still eating a sandwich. Yeah, of course, good luck with your programming journey. I just got a bunch of jelly on my finger. I gotta go wash my hands. I'll be right back. All right. Hands washed. Breakfast eaten. So I'm just recalling how this all worked. There's no proof you washed your hands, I know. I don't have a camera. You guys will just have to trust me. I was eating a PB&J though, and I got jelly on my finger, so I didn't want to get my keyboard dirty. Not that my keyboard's like that clean, but like sticky things, no. Trust is to be earned. Dang, you're right. This was just a recursive. Oh, thanks, Not Slither, for the follow. This is just a recursive descent parser though. But in crafting interpreters, what he does is along the way he's just emitting bytecode. And I think I don't want to do that. I think I want to do two things in I think for the parse, it's going to be tokens. And the compiler's kind of like pulling these out. Or it's like scanning. The compiler gets the scanner. I think it calls like next, technically. And that gets the next token. Then you've got your text file. Which we have all of our code in. So that's going to get tokenized. Then we've got our compiler. I might call this a parser though. This is going to do recursive descent. And it's also going to do expressions with a Pratt parser. Which I think this stuff's all working. I just need to include it. And then I need to change the tokens and then decide what's going to be emitted from the parser. Sometimes people do ASTs, which seems like a pretty reasonable choice. I'm just trying to think of how I want to go with this. I definitely want a type checker. I definitely want a type checker. And I also want a symbol. I think out of the parser, I also want a symbol table. Which will have types. And what you call them? Functions. Because when we emit the final C code, because I think what's gonna happen is there's gonna be some intermediate representation thing, and then we're gonna generate, like this is on the other side. I don't know exactly what's gonna be in the middle yet. And we'll do two things. It'll be C code, and then we'll also do bytecode. That's what I think. Hey, bro, you're doing a great job teaching us this. Thanks, buddy. You're doing really great. Thank you, buddy. Appreciate it. Yeah, let me know if you have any questions. How do you go about doing all this stuffs? Which stuffs do you go about doing? Or which stuffs are you asking about? A lot of this code comes from this book, Crafting Interpreters, which I had somewhere. If you guys want to check it out, it's from this. I might start with a bytecode though, but I do want to do type checking. I don't think I can do type checking on the bytecode, so I think this will have to be like a 2-pass thing. So pass one will be generating the AST, I think. We'll just start with an AST. I don't know why I'm like optimizing this in my head. I think it's pretty reasonable to just have an AST. So we'll try to emit an AST and then we will generate C code. I was trying to keep this first stage thing, or this like first draft thing, as simple as possible, because I want to bootstrap the compiler with the like first draft of this. I just don't know if I really need this stuff. I could, I'm trying to think here. There's probably a way to do this without generating an AST. So I might do that actually. Because I'm gonna have a bunch of C code and then I'm gonna have to migrate that to this other language that we'll be building. So I'd be fine without doing type checking for now and just generating C code. That will get type checked in C, right? It's just the errors will be on the C build, not the actual build. So I think what we'll do is we are going to, hold on, I might write this down. Now I'm remembering. Yeah, so when we're parsing, we'll keep track of all of the symbols, all the function protos. Then we have this, because we need to emit these in the correct order, and it's just gonna be a Unity C build. So it'll just be one big file for the C compiler. So we'll do all the struct type defs, then we'll do all the function protos, then we'll do all the struct implementations, then we'll do all the global variables, which is I guess you can have global non-constants, so yeah, all the globals. Which these might have to be like emitted in the correct order. And then we'll do all the function implementations. And because we've hoisted all the function protos to the top, we're basically safe to implement these in whatever order. Do you also make a living writing code, or is this just a hobby? I have made a living writing code. I don't work it right now though. I'm on a sabbatical, you might say. But I'm making most of my time I spend making this video game called Mythfall. There should be a link somewhere you could play it if you want. And I'm trying to release it next year. But I sometimes will do this like programming language day of the week where I just work on building a programming language for fun. So that's what today is. But usually I'm working on Mythfall. How is AI affecting this? It's not, I don't think it's affecting it at all. I sometimes will use like ChatGPT to understand things or learn things or like summarize things, but I don't really use it for generating code. Yeah, so let's rewrite the parser to emit these different sections. I don't know. Maybe I just do an AST. I'm just trying to think here, like what's because if I do all of my code generation stuff inside of here, and then I have to eventually, like if I generate the code from directly this parser into the three different, or like the multiple sections we have, because we've got different sections. We're gonna have one for types, one for function protos, one for struct implementations, and then one for function implementations. Like I could go through and probably emit that stuff. It's just that then all my code generation is locked into my parser. So it's kind of nice to like emit it to something else. That way when I change it in the future, because I know I'm going to change it in the future, it'll be easier. All right, let's try to just do an AST, I guess. So we'll do an AST, then we'll walk the AST and generate an output. decided. Okay. See, this is what I'm saying when you have to like hoist weird functions just so they can call each other. So we want the compiler to automatically do stuff like this. I'm gonna try to throw a new file here though, parser.h. Wait, what is this? I'm in the wrong one. Parser.h. We'll do this. All right, I think this is where the compiler stuff starts. I'm basically kind of like keeping the same structure of the original program. I'm just kind of gonna replace everything that I don't need. Like this needs to be part of the parser. This needs to be part of the parser. This is probably part of the parser. It's not super clear to me what the difference is. That's fine though. Okay. I'm just gonna comment out, or I'm gonna put everything that's a compiler function. I'm gonna throw up here and comment it out. Declarations is a parsing as part of the parser. This is the synchronize function. So when there's a panic, it'll go into here and then it basically like filters all the symbols. It just keeps pulling symbols out until you eventually get to something that where it can resynchronize from. This is parsing while statements, return statements, print statements, if statements, for statements, expression statements, vars, funcs, all the stuff, methods, functions, block scopes, expressions, get rule. That's for the parser for expressions. Sorry, I just have to look through each of these. Declare variable. Add up value. This is a compiler thing. So is this one. This is for closures. Which I don't even know if I would add those. Current, add local. What is, that was weird. I think this is current compiler. Yeah. I'm kind of putting these in reverse order. Just not super good, but. Grouping, literals, dot expressions, compile call. Oh, this is just a call expression, but I put this in front of it because it was colliding in the build. Argument list, parsing, scopes. These are part of the I'm just gonna have to keep throwing this stuff over though, if it ever uses the compiler. Though it is a little weird though, because we kind of do this compile function. Parser had error. But I think the parser is going to generate the AST. So, all right, then we have a init compiler. So I ordered from Amazon, A+ CCNA books. They are massive, 1,000-page. I'm terrified. Anyway, how are you going? I am good, yeah. That sucks though. I mean, if it's super in depth though, that sounds about right. It's not abnormal to have super long computer books. Current chunk. But as a collector, I love the smell of a new book. Nice. I can see it. And digital books seem so awkward for me. I don't know why. Yeah, I'm not a huge fan of reading digital books, but I've kind of gotten used to it, I think. Yeah, so this starts the scanner, and then we can start using the scanner to pull stuff out of it, I think. Let's go ahead and grab this function, this compile function. I just want it to be nearby, so I can reference it. Yeah, we need to initialize the scanner, then he builds a compiler, initializes the compiler, and then he kind of resets the parser. I'm gonna pass the parser in locally, I think though. Actually, no, I'm gonna make it global for this version, but when we do our bootstrapped version, we'll make it a method probably. I just think at the start, it'll be simple enough to where we don't need method, or we don't need this level of stuff. We'll advance, and then we'll then essentially all your file is you match every token. You just keep you keep looping through declarations until you match the end of the file, and then declaration is going to be in here. So it's basically looking for like the class keyword, or it's looking for the function keyword, or it's looking for the variable keyword, and then this stuff calls specific functions. This is how recursive descent parsers work. Okay, what else? Yeah, and he parses the entire thing as a function, and we'll return that whatever error the parser had. Is the other feeling of holding your hands instead of digital? It's psychological? Yeah, maybe. But there's also like Kindle, so you can kind of hold it. I just feel like the typography is not as good for those. Like the diagrams are in weird spots, or like doesn't fit correctly because the book has a custom size. But I feel like, I don't know, I read stuff so much on the computer that I'm just kind of used to it at this point. All right, parser undeclared. I thought I had a parser. Yeah, here's the parser. However, we need to actually this is gonna be different. Because it's gonna be parser to AST, and then we're gonna do semantic analysis on the AST, and then we're gonna generate code. I think. So then in parser, I'm gonna go ahead and add, it's weird this returns something, but it's that. Oh, I see. But essentially outside the parser, we want to return an AST, which will basically be it's going to be a tree, and it'll have one node at the top. So let's make a node type, like AST node or something like that, right? Parse const car star source. Thank you, Mint Grelly, for the follow. Appreciate it. I'm gonna call it parse source. How's your studying going? I remember you studied something new. Yeah, I was going through the crafting interpreters book, and I just finished it this morning. Which is actually, it's a long book. I didn't realize it's like 600 pages, but I definitely learned a ton about how languages are built. So now we're putting our knowledge to the test. Yeah, and this is going to return. I guess these will have to be a tree, so it'll be a node pointer. Oops. What's your studying type? Acoustic, optical? I don't really know. Like, you mean like listening to people talk or reading it or watching videos or something? I think they're all pretty useful in their own way. I think it's good to just like do a variety of them, I think. Also, one thing that's helped me learning is as I'll read something in the book, if he doesn't cover it, it's nice to just like use ChatGPT or something to be like, hey, like, explain this concept to me, or like, does this work like this or like this? And usually they'll give you like a pretty reasonable answer. I mean, you can also Google this stuff. Just sometimes it's hard to find like someone asking the specific question that you just asked. Thank you, Oska. Thank you, buddy, for the follow. Appreciate it. Welcome. I mean, the method you use as a learning type, like if you learn something better by listening, use some kind of roadmap, explain it to someone. I don't know, honestly. I've never thought about that. I guess probably reading. I feel like most of the stuff I've learned from reading or like doing it myself. Actually, I don't know if I'm that good of a reader. I think more like I need to like try it and experiment and stuff. That's my learning type, is experimenting. Experimenting and failing. That's how I learn. Okay, I'm gonna make this a void though for now. Just because I want to get this build running. So instead of running compile source, we're gonna do parse source. And then outside of this is gonna be we're gonna get an AST, so it's gonna be like AST is sort of deal, but for now we'll just try to run this. Yeah, we need to include this new header. Parser. So we have the scanner, which the parser depends on, then we're gonna have the compiler, which depends on the parser. I'm not gonna do the weird if def c include thing. I'm just gonna include them all from here. Because we're trying to bootstrap a language, not build a perfect C thing. OP loop. And parser. Shouldn't this be in token? Oh, I remember now. We have precedences. I actually don't remember where these are. Oh, these are for the bytecode. So this stuff needs to get removed because in crafting interpreters, he emits a bytecode straight out of the parser. And so in the bytecode, you've got like operator, and then you've got like operand. And the bytecode just looks at the instruction. It's like, this is exactly how CPUs work. Looks at the instruction and then decides how many operands to pull off, and then like executes it. So like this would be like an add or a subtract or a divide or something like that. And the operands are just like stack values, or not stack values. They're just values assigned to whatever you're doing it on. They could be on the stack. They could be heap allocated, but they are somewhere. So yeah. So we don't need to deal with those because we're not doing a VM just yet. Okay. So let's go to our parser and we'll just go through these errors. Yeah, this is for emitting, like a lot of this stuff is for emitting bytecode. I almost want to, like what I want to do here is I want to rip out all the bytecode emission stuff and I want to instead generate AST nodes. Which I wonder if it would be easier just to emit C code for now, and then when I rewrite it in the language, I just don't know if there's going to be something that I'm missing, like some reason that we can't do this. Let's experiment. I've done AST to C directly and it worked pretty well for me. Yeah, that's what I did in my that first draft thing I was doing a while ago that I wrote in Golang. I'm just deciding, because like one of my goal metrics is I want to do, I want to build this mini language and I want to build a C compiler that generates C code for this mini language. And then I want to use that mini language to build the like full thing. If that makes sense. I want to bootstrap it as soon as I can. So I don't want to spend a lot of time doing an AST generation if I'm gonna like rewrite how it works anyways. So what I was thinking of is as I'm parsing it, just emit the C code like directly and don't do any type checking. I just can't, it's hard to know ahead of time if there's going to be something where it's like, oh, I actually needed to know what that was. Yeah, that was kind of my thinking. So it's either I go through the parser and I generate an AST, or I just emit C code. I might just try to emit C code. Your views on handwriting notes, is it effective? In college I did it. I thought it was effective. I didn't like go and rewrite my notes, but it was always helpful for me to, especially for like math stuff, to like, it's always helpful for me to do it myself when I'm learning something. Like I'm a very like hands-on learner, I think. Let's just try to emit C code and then we will, we'll try to emit C code. And if we get to the point where it's like, this isn't gonna work, we'll just give up and we'll switch to an AST. All right, I like that idea. I like that idea. All right, let me think about how I'm gonna go about doing this. This is all Pratt expression parsing, which in some weird way, I might not even need to do it. A few tricky things that I think are going to be are, well, hold on. I wonder if I'm just going to have to refactor this anyways. I think I'm going to have to rewrite everything, I think. All right, let's do this. Init scanner, advance, so we need this function. Which is here. I think mine was recursive descent instead of Pratt. Yeah, I use recursive descent for statement parsing, and then when I get to expressions, I use a Pratt. I'm going to use a Pratt parser. Yeah, so once I get to an expression, I'm going to use Pratt, but before that, it'll just be a recursive descent. Yeah, how he did it in the book is he does this like rule table. Where is it? Maybe it's not in this. Oh, it's in the compiler, I think. Like he's got this rule table, and then he looks up what token it is, and then he can determine if it's a prefix rule or these are function pointers, if it's a prefix rule or an infix rule, and he says assigns the precedent, and it works pretty well. So it's nice because every single new token you add, you just have to update this. Yeah. Because the other one I did recursive descent all the way through, even for the expressions. And it was super hard to keep track of. So this just runs inside of a loop and decides like which, how to group things based off the precedent, which is super handy. Oh, this is the equivalent one. I don't know why I couldn't find it. All right, let's look at the advanced function parser. Then we loop forever. And maybe it's worth it to do an AST. I'm just thinking, like I'm just looking at this code that like I would need to generate. So if this was a pointer, I'd have to do an arrow based off of a dot. So that's a hard conversion to do without knowing the node. Without knowing the type, actually, that's a hard thing to do. So I probably can't do that until I have type checking. Then an if statement. I could probably omit the parentheses myself. Yeah, I think most of the time, if I can't parse it, I'm just gonna omit it as is, and then you kind of have to embed C code. I think this will work. We'll see though. We'll at least try it. This doesn't have to be perfect. It's just gotta work. And then we'll slowly migrate that. Like, cause what'll happen is we'll have this new language and then we'll just, the compiler will be written in it. So then when I want to change a feature, I can just compile it to the next version, you know? That's my hope at least. All right, error at current. These are just error pop-ups, which we need. Parser current type, token error. So we need scan token, which is in the parser. We've already written that. Where's my match function? There it is. Match is easy. It just depends on check, which is just checking the token type matches, and then it consumes it if we need to. This one just returns an error message if it can't consume it. All right, and then we're looping through and parsing declarations. So that's this one. And all right, let's go ahead and look at our test.txt. Let's decide what we want to parse first. I guess the main function makes sense. I'm gonna comment this out here. If match token bun. I'm gonna change the token though. Oh, in the Lexer, or no, it's called scanner. He does this prefix tree. He does it FUN for it. I want to use func. Like this is one of the first things I want to rewrite because this is just nasty to update. Then we have func main parentheses brackets. This might work. Oh yeah, func declaration. Parse variable. See, the problem is this is where it gets into bytecode emission. Like parse variable, I'm pretty sure emits bytecode. Yeah. One second. Sorry, my cat's tail was right next to my wheel on my chair, and I rolled back and I pinched it a little bit. I don't think it was that bad though. She didn't like yell at all. She just got scared. Poor cat. All right, sorry about that. I know. I just like, I can't see her when she's behind me, and then I was like just rolled back and she was right there. I think you just pinched the side though of her tail. So I had to go make up. Jeez. All right. Whew. I need like, I don't know what to put behind my chair so that that doesn't happen. Like I just don't want them to just like lay next to my wheels. I need to get them like a bed or something so they can sit like up on my desk or something like that. All right, what were we doing? Honestly, I just gotta learn not to do that. The problem is they like, she's not gonna sit there for a while, but then eventually she'll come sit there. You know, like she'll forget after some time. Also, this one wasn't that bad. Like, cause she didn't make any noises or anything like that. She just the fur got stuck, I think. But yeah, it's just like, I just hate that this happens. I hate that this is like a possible thing that could happen. All right, what were we doing? Functions. All right. Function, type function. Yeah, so I guess if we're just emitting C code the whole time, I might just do like global regions of new plan, roll over the parser, bootstrap the cat. It could work. It could work. I'm just thinking, I guess I'll just build a long string for each section that I want to emit to. I am gonna put these, I think when I do a function declaration though, I think what I'm gonna try to do is, I think I'm thinking ahead too much. I was gonna say like, I could maybe parse an AST node, not put it into a tree, but just parse it and then emit it. But I think I'm just gonna like literally parse and emit the whole time. Wait, how does this work? Mark initialized. Oh, then it does function. This is the actual parser. So there's a function. Yeah, here we go. I don't remember what type function type is though. Type method. Oh, I think it's for that, isn't it? Which I don't think we need that technically. This is in the parser. What are we calling? Oh yeah, because we're calling that. Okay. And then we define a variable. So we don't need to do this. We don't need to do this. We're just going to parse the function. And that's this code. I mean, he does it. He makes this his own little compiler object, and he parses the function with this new compiler. So we'll do, we're just kind of like scoping in to some degree. Oh, we also call it begin scope, which is a compiler function, I'm pretty sure, yeah. I'm just gonna rip those out. It's match. Does match consume? Oh, match does consume. That's right. So the func keyword or the func, keyword will get ripped or will get read, and then we'll do then it'll be the name. But I kind of just want to put this in here. Like, I don't see a reason to not. The only reason he did it there was because he wanted to put the name. Okay. Then we'll do, well, the problem is I need to read the thing. Token identifier. I'm curious what this used to have in it. No. First variable. Yeah, it reads it. Okay, let's just keep this. We just won't emit. Declare variable. Scope depth. Token. Parse previous. He's looking through like the local variables. He's doing semantic analysis here. Then he adds it. So we don't need to do that. We do want to consume it. Current scope depth 0. Yeah, so if you're if you're a function declaring inside of a function, then you wouldn't be a then it wouldn't be a global. Okay. Boom, boom. Yeah, parse variables is not exactly what I want here. It just feels easier if I just pull this out into some data structure. I'm just going to do that. And then I'm going to emit it at the very end. So like, for example, when you parse a function, I think it's pretty reasonable to just do something like this. Like token name. Then I can get rid of this stuff. Left parenthesis. If there's no right parenthesis, then we start this loop. What's up, Marticus? How's it going? But eventually we'll consume the right parenthesis, and then we'll do the body, which will be a different parsing function. And then in compiler, we don't care about that. We don't care about this. We don't care about that. Because we're just going to try to generate this func node. Start a little game in Golang. Nice. What are you using for it? Like, are you using Evit engine or something? Nice. I recommend. It's a good one. That's cool though. Exciting. Start small. Oh, we can use this to get the previous token. Perfect. So we'll consume a function name. Just some algorithm stuff to scratch my programming itch. Work has been slow. Yeah, I feel that for sure. Parser.previous is the token that we want. I guess we do a token, wouldn't we? It would be a pointer. But I think tokens have a token is a token type pointer, a length and a line. So we can just copy this. We don't need to make a pointer. I don't know why this does it that way, but I don't remember. But I guess we'll define our return type, which is going to be this func node. I don't remember. Can you just do this and see? Set all fields of a struct to 0 in C. Yeah, you just do this. Perfect. And then we'll do func node dot name is parser.previous. Maybe this is going to be a little bit complicated. Because now I need like some sort of array to build this. Like, because for arguments, I would need this, right? I need like, sorry, this is Go syntax. What I can certainly do, I just don't know if it's worth it. Let's just not. That was an idea. I think it's not going to pay off though. So we'll do this token, func name. The one big challenge I have here though is that in Go, they reverse the return type is at the end, but I need to admit it at the beginning. So I can't really emit live, can I? Stuff like that always gets me. I use 3 languages weekly. It's a broken record. Yeah. Well, I'm not like that familiar with C. So I'm kind of learning it along the way. But just little syntactic differences get me. And also I'm not used to having to think about how I'm going to allocate things. Like allocating free. I'm tempted just to do like this. I don't remember the syntax, but it's going to be like, this is probably backwards, isn't it? Oh no, I think you put it over here, don't you? Then we have the token name, and we have the token type. I guess we just do 255. It doesn't really matter. And then we'll do arguments, arg idx is arg. So we'll do an identifier for the name, then we'll do the type right after it. This will be also an identifier. I think you have to do what? Name equals type equals. All right, let's ignore the block. Oh, whoops, this has to have a name to it. It's gonna be a arg. Type def struct token name. Oh, whoops. Yeah, this is one we don't want anymore. current undeclared. Oh, this is the arity. So we'll just keep track of the arity here. Yeah, that sounds about right. Missing semicolons. I'm pretty sure that's the syntax. I guess not. Let's just do C struct initialization syntax. Oh, you don't have to do this. I don't know why I thought you had to do that. Oh, arg index plus plus. Which I guess is the same thing as the arity, isn't it? Man, these warnings are pretty rough. I think arg parenthesis. Oh, you might be right. Oh, I think I think you're right. For composite literals, I think you do this. Or you can do this, I think. I can just do that. Okay. Oh no, the dot syntax does work, I think. Is it this? Okay, yeah, I think you're right. You needed the parenthesis there. Yeah, it didn't seem like I could remove it. At least that didn't work. I think it expects this. It might be like a newer version than I have on my compiler. I'm using TCC. Okay, here's the synchronize function. This one just, if it detects a panic in the parsing, then it just loops back, or it pulls through all of the tokens and then eventually resolves the panic. That's weird that it didn't end. We must be in some kind of infinite loop. All right, parse source until you match a EOF declaration. What are we working on? I just finished doing this crafting interpreters book. Now I'm trying to build a little language. Kind of based off what I learned. And I want to generate C code, then I want to bootstrap it in this new language, the whole compiler. So that's what I'm working on. So I'm just kind of learning and having fun. A little experimentation going on. I think the problem is I need it to, if I recall correctly, writing in Go, right? Yeah, I did write one language in Go. And then I read the second half of the book and then decided to kind of start over. But yeah, I had pretty much not a fully fledged language, but I had like a pretty close to fully fledged. Minus a bunch of like type checking errors and stuff. The type checker was not very good on that. But I had like generics and I had like foreign function calls and stuff like that. So it was pretty far along. Yeah, what's happening is it's not parsing the block. Because I don't want to do statements yet. let me just go here. What is in this file? We'll do the block scope. I removed this, but so we consume the left bracket, and then we just want to have the block function consume the right bracket. So we'll comment out this section, which does all the declarations. I guess this is fine. More C-isms. Does it still compile transpile to C? Yeah. This new one or the old one? The old one still does. But in the book, he has you build a bytecode VM. The new one? No, the new one hasn't done anything yet. We're like still trying to get the parser done. But I'm trying to get it bootstrapped as soon as possible into the new language so I can like build features iteratively. So I'm trying to build it with like as minimal things and build a really thin layer on top of C. Wait, I was gone. Why not Go? What do you mean? Why am I not using Go? Or why am I not building it in Go? I guess I'm not building this version. I'm not building in Go. I'm not bootstrapping it in Go because the Go way of doing it is to use interfaces, and interfaces are not really a concept that I want to like experiment with. So I'm more using like tagged union type polymorphism rather than like interface type polymorphism. All right, let's go ahead and just do this. We'll do printf. We'll do a slash n. Oops. The problem is that there's no like failing out of this if it can't find something, you know? It's like if I can't match any of these, I guess I would have to default to statement. Let's look at that function. Yeah, it just recursively goes through. The problem is it's not gonna ever, like I'm not sure what it's hitting that it's not finding, unless it's not finding func. Which could be the case, because I did, or no, it's in the scanner. FUNC. Oh, check keyword. It's not checking the last one. Start length. Yes, we need to make this a 2. There we go. The prefix. I messed up the prefix tree search that was there. All right, we're getting closer. I do want to start emitting stuff though, along the way. That way we can have like an output file of C and we can reference the two. Though I'm not sure exactly how best to do that. I think I build a string. Like, I think I just want to push, I think I just want to push characters onto a string. I'm not really best sure how to do that though. Let's see. I think I would do something like this though. What distro? I use Arch Linux. Arch Linux, by the way, in case you guys were curious. Don't know if you've ever heard of it before, but it's called Arch Linux. Dun, 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 dun. Okay, we want to do this is the so we'll make a string type, and then we'll do make a function that's like or sorry, this is gonna be a void push string. I'll just call it write. Or we need to write to the string. That'll be the string, and this will be like the, I don't know, data. Okay, and then we want to do if stir. Am I doing this backwards again? Sorry, my Goisms are killing me right now. There we go. If stir is null. Oh, we have to do parentheses. I might rip some of these functions out. These are just like array macros that he had written, which are kind of helpful, honestly. He does it a complicated way though, because he's trying to add a garbage collector on top of it, which I don't really have to deal with. Let's not. He must call Malik. What happens if you do free pointer. So I'm just looking at what he does. Result is right now. What happens if you pass a nil pointer to realloc? Null pointer. Okay, if you pass a null pointer to realloc in function C, it behaves exactly like malloc. At least according to the AI overlords. Or sorry, stir.start is null. Then stir.start. Then string.start. We want to realloc that pointer with size of. I'm just gonna make up some starting size, like 64 or something. I guess I want this to be more of an array though, don't I? We'll call that capacity, we'll call this length. We'll just do linen cap. I'm just gonna say tr. Okay. So we'll realloc and then we'll do we'll do the cap is 64. 64 elements can go on it. I wonder. No, I'll just do this one. I was thinking like it's getting very close to me just building an array wrapper thing. But I don't think I have very many cases where I need arrays. And if I use an array, I'm just gonna, or I mean, I might just do them statically sized. Thank you, Baldy, for the follow. Appreciate it. Welcome. Okay, that'll at least get us started. Oh, this is kind of a complicated function, isn't it? I'm just thinking through, like, I need to look up the length of this. Do I do this, write one, and resize it? This is gonna be a const also. Most of the time, I think. No, we'll just for or actually we're just gonna do a for loop, aren't we? And then it would be bum ba-dum bum ba-dum bum bum dun 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 dun. I'm gonna call it I. Or really it's I don't remember the C syntax for this. So we'll just do a break statement. If we're the nil character, which I'm pretty sure is that, then we break. I guess it's this, isn't it? Okay. Sorry, I just had to All right, I should have think that through. I think that works though. Then we want to add characters one by one, essentially. I might just do an add function though to the string. I'm just gonna pass a character C, and this won't be efficient, but it'll be easy. Yeah, of course I'm gonna do these all wrong. That's such an annoying C thing. Okay, we'll pass the string into this add function. This one's going to basically do a check if length, if string dot length is equals strength cap. It will reallocate. I think reallocate copies stuff, doesn't it? A realloc that increases the size of the block will retain the contents of the original memory block, even if the memory block cannot be resized in place. The old data will be copied to the new block. For realloc that reduces the size of the block, the old data will be truncated. Okay. So we can realloc this. Length will stay the same, and strength.cap is going to be 2 times the old strength string.cap. And then we can do just add that character. So it'll be string pointer at length. Sorry, this is wrong. Oh yeah, add to the string this data. Yeah, this one needs to know where we are on the string. This is more like a string builder, I guess. Then this could be more efficient because I could check and then do less reallocs, probably, right? But if I'm doubling it every time, it might not be that big of a deal. But I do have to do this check every single time I add a character. But for now, I'm just gonna do this because I'm not really caring about performance. Yeah, we add. So we do length, because the length will be 0 at the start, and then it'll be the size of the capacity. So then this will fit, yeah. And then we'll do length plus plus. Like so. I'm pretty sure that works. I'm pretty sure that works. We don't need to worry about null character tracking here because this is like a sliced string. It's not a C string really, but that means when we print it, we do need to convert it to a C string. So let's start a quick function for that. I'll just call it 2. Ugh. I'll just say 2C string. And this is gonna return a const car star, or no, sorry, this needs to be the return. Like that. And then all we're gonna do here is we're gonna do a string, sorry, add string with a null character. And then we'll return. I don't know if I can return a constant. I guess you probably could, right? You can probably go up to a constant. But yeah, we just need to return the stir pointer. So this is just, all this will do is it'll append it. We're not going to modify the length though. So the next time the length gets added to, oh no, this will update that, won't it? So we'll add, then we'll decrement the length. Screw it. We'll decrement the length. That way it's not a part of our string in terms of our string builder, but it's a part of our string in terms of the C string. But the only downside is as soon as you add again, really what you should do is copy the memory over. I'm pretty sure I even have a... Sorry, let me just look at this. I might even have a function that does this. Like copy or something. Whatever. Like really you should allocate memcopy and then have this pointer. Or have a, like return a pointer. I'm just curious if this will build. Struct or union expected. Oh, because we reallocate, so string pointer equals. I think I need to cast this to a car star. Oops. All right, cool. I'm gonna make a global output. Oh no, I can't. Can I do this? I'll just say output equals string output. Yeah, that's right. And then this will handle itself if it's. Oh no, it will be nil at the start, won't it? Oh no, because we'll just pass a pointer to this everywhere. Perfect. All right, let's go to our func declaration. Then we'll go to our function call. And for now, all I'm going to do is this. Write output. Write output. Function name dot. I don't remember what the token is. This time I'm going to move though. It's going to be dot start. Okay. I'm just going to make a file string.h. Then in our main, I'm going to import that. Okay. Func name dot start. Then at the end of our main function, after we parse the source, I just want to print out the output. So it'll be what do you do? Printf %s, and then we'll do output. Or what did I call it? To C string output. Null. But it built. What am I building? I'm just working on a little experimental language idea that I had. So I'm working on building that. Right now we're building the like bootstrap part of the compiler to get us like an initial compiler for building our language on top of it. Like I'm trying to bootstrap it in its own language as soon as I can. So I'm trying to build the minimal infrastructure in C to build my language with like no type checking, no semantic analysis. So yeah, that's what we're doing. Oh, this is just printing the null character, I think. Was it like that before? Hold on. No, never mind. Why is it printing all of that? Right. Thank you, furry monster. Thanks for the follow, appreciate it. Welcome. All right, let's go to our parser. Let's understand this. Funcname.start. Oh, I know what it is. Because we need to write a specific number of bytes here. Because this token, I just forgot how this, like the null character for this string is the end of the file. So what we need to do is add a length to this write function. So I'm gonna make a function that's like write token, I think. Compiling Go programs. I'm just building a little compiler. I'm trying to build like a little Go-like language, and yeah. I just finished reading the book Crafting Interpreters, so I'm a little bit on the. I'm interested in languages, so yeah. So we'll write to our string the token. The only difference here is, well, this part's similar, I guess. But, sorry, I need to reorder these. Main string actually has to go before token, unless I put, nah, I'll do this, whatever, it doesn't matter. Okie doke. Then we have token. Then from token, we're gonna have a new length, and we're also gonna have a, we're not looking for this though. We're technically going from 0 to I is less than token dot length. It might just be l.len. Oh no, it's this. That's the length of the token string. So we're just writing the token to this buffer. And then in our parser, sorry, my cat was wandering around my wheels. I didn't want to run her over again. Yeah, so this was our original attempt, but that's gonna read the entire file. So we want to do write token. We can use this though to do like write hello. And then write token will be, we'll do to the output, and then we'll do func start, func name. Yeah, just func name, because that's a token. Data is undeclared. Yeah, so then it's token dot start, I think. Oops. I forgot that's not a pointer. Cool, so we got the function name printing, and there should be a hello somewhere. Like we should see this as well, unless I didn't save it. I did. Parse source. Oh no, hold on a second. We want to see the word main. Because our test file is just like func main, and we're just trying to print this. I'm gonna go ahead and do this. Let's go to our main.c. Just to see if this stuff works. It looks like it's not working. I don't know if it's a C string thing or something wrong with our write function. Oh, I forgot. Didn't I fix this? I thought I fixed that. Oh, I did it up here. Oh, I did it up here, but I didn't do it there. Okay. Hold on, let's just do this. There we go. At least stuff is there now. Add data I character. Boom, 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 boom. Am I not bumping the length or something? This is how you print strings, right? Isn't it? Let me get my cat food, hold on. All right. I like you, Dylan. How's it going? How's your stream? Thank you for the raid, buddy. Appreciate it. We're doing a programming language Monday, so you have to watch me struggle through some C code today. Boom, ba-dum, boom, ba-dum, dum. Right now we're dealing with some C string stuff. So yeah. Boom, 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 boom. But thank you, buddy. Appreciate it. Let me just do some testing really quickly. Okay, that works. So that printing should be okay. Oh no, that's okay. Yes, we maybe realloc. Dun, 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 dun. We maybe realloc. Thank you, Funke, for the follow. CH root. Is that middle pointer? We're doing a little bit of programming language development today in honor of Programming Language Monday. Bum, ba-dum, bum, ba-dum. But it's been a while since I've done C, so it's a little bit of a struggle bus. Yeah, data I. And this one, yeah, this one reads till it finds the nil character, and this one reads till it finishes the going through the length of the token. So that should be okay, and this one I think is okay too. So, I mean, something could be wrong with my realloc part. Maybe I could consolidate those. Oh, wait a second. Oh, this is if it's nil. I'll just do this. No, I can't. We'll do alloc. We'll just do this first. But then when we add, we do need to check, but at least I'll have some memory allocated to it. All right, let's do this. We'll do alloc string output. Yeah, something must be wrong with this portion then. Something's wrong with this add function. We definitely have enough for that. I'm just gonna remove these just because I'm curious. Or something's wrong with this. Dun, 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 dun. I guess we could return a different. It was intentional to not assign the character. Oh, you're completely right. How did I miss that? That's exactly what the issue is. Oh. Hold on. Oh, segfault, nice. We're getting closer. Thank you, really good name. Appreciate that. I'm just logicking through this thing here. Or let me, let's remove this stuff. So we'll just try to get this right function working first. Okay, right. We loop through until we find the nil character of this message. Unless I'm wrong with this. Is that the nil character in C? I just gotta check my assumptions. Yeah, \0. Yeah, okay. Dun, 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 dun. String pointer at the current location. Bum, 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 bum. I'm not sure if there's a reason, but I think you need a valid pointer before calling realloc. No, I thought I googled it, or maybe I could be wrong. I thought realloc you could. I thought realloc if you pass a nil pointer and it falls back to malloc. But we could try that. No, I mean you could be right. What am I missing? Oh, you don't pass a pointer in. Duh. I mean, this is technically more correct, I guess. All right, so then we've got... It's like it's not going into this loop at all. Rise 0. Where data at I is not the null character. Is this some weird like C thing I'm just missing? We'll do this. Yeah, it's not entering into this loop for some reason. Oh my goodness, you're completely right. Kill me. Oh no, it's still not working. Wait. Yeah, not equal to. Do we see any dots? Yeah, okay, cool. Test message, perfect. Then we get right, test message, perfect. All right, you're right. You were right. Dang, dude. Okay, we need to go slow with C. Thank you, Carmuza, for the follow. Appreciate it, man. Welcome. I told you guys it was going to be a struggle. This is like Go programmer learn C, so. What does the syntax look like for the language you're working on? Yeah, I mean, it's going to be Go-like syntax. That's the syntax that I like. Right now I'm working on the like parser code generation portion. Or this is more like the Lexer. So we have like this portion done, and now we're parsing statements, doing recursive descent. I'm kind of adapting the code from, what's it called? Crafting interpreters. And then I want to be able to generate two things, C code, and I want to also generate byte code for to run in like a VM at runtime. But it's going to be like a mix between, or what, I mean, this is like more like me messing around. I'm not really like trying to build a production language, but my interest is in hot reloading code blocks with the bytecode, but then also having like a production build that compiles to C code, doing that, and then also having like some simple comp time stuff, and then also some like generic facilities, but then mostly making like a C language, or sorry, making like a Go-like language that uses arena allocators rather than a runtime. So like there's a few little things that I want to do, or that I want to mess around with and see how it goes. Because I like Go a lot. There's a lot of things, because I do game development primarily. So there's a lot of things in Go that is really hard to do for games especially. So having more like compile time facilities and stuff like that, like kind of pulling from like Zig and maybe a little bit from Jai, but also keeping it like simple. Because I think those languages have gotten a little bit complicated. Not that I've ever used Jai or anything like that, but. Thank you, Nihil, for the follow. Appreciate it. Welcome. Okay, let's put this back. Dun, 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 dun. Wouldn't you love Odin then? I have looked a lot at Odin. I think I would like Odin, yeah. I haven't used it. I've looked at the code a lot though. Or sorry, I've looked at the documentation a lot. I've never actually like installed it and used it before though. Odin maybe doesn't have as much comp time stuff as I would be interested in adding. And I don't know how the, like one of the big things I'm really interested in is having like a compilation mode where everything's loaded as like a bytecode block. So every function goes to some like VM block, like code block. And then you can live change your code. Like you can live edit your file, have it reload this function block, and then re-implement it. I think that'd be a really interesting way to program. And how you do it with Odin and most other languages is you would build like one section of your code to a DLL. And then you hot reload the DLL. But I think it'd be cool to do like some interpreted thing for debug builds. So you can like live edit stuff. Looks like a lot of work. I like game development, but I am no interested in technical side of working on shaders and graphic effects. Oh, I'm more interested in the technical side, like work on shaders and graphics effects. Some of the DLLs, yeah. Yeah, the downside with DLLs, I think, is you just, there's not as much you can reload, But you can definitely reload a lot. And also this would be more like incremental, I think. So it'd be less of a full reload, if that makes sense. The DLL approach, yeah. Yeah, that's like probably the most common thing. But yeah, I think Odin's a good language. I don't know how I feel about not having methods, but like, I don't know. It's like, I don't know if I'm just being like too like particular about like what I like. Like I'm sure I could probably use Odin, but just like having methods seems like super nice to me. But I currently am using Go to make my game, which is fine, but the hot reloading in Go is atrocious, so that's something I wish I prioritized more, I guess. All right, let's try this. Our source, hello, test message. I think write token isn't working. Oh, right. Hold on. Maybe this didn't quite fix. Oh, I deleted that section, didn't I? Okay, that's why it's not showing up. Okay, test message is good. Now we're not printing it from there. That was the wrong spot. We should build write the token though, which is a different function that loops through the token length because there's no null terminator for that one. Token start. I think that's right though. So I do parse source. Yeah, let's look at this. Yeah, we print out parse source. Okay. Right? Output. Oh, I'm allocating after, silly. There we go. Okay, so the function name is main, so we should be able to output that like this. Okay, cool. Now we have like a string builder. That'll be really handy. And we can do all the stuff, I think. So let's go down here. After we parse the block, then we have we'll have our list of arguments. We'll have our list of arguments, and we'll also have the arity calculated. And let's see if we can loop through all this data now and generate like a blank function. What's up, Buzztronic? I'm making a programming language for fun. Hey man, have you heard of a game called Wildland? It's also a I believe. Not sure what programming language they used to create it though. Yeah, I have heard of that one. Yeah, a few people have posted in my Discord. It looks good. It looks more like room-based, I guess, which seems cool. I tried it out though. I played on the browser. It was fun. Seeing you worry about null terminators and having to keep track of what you allocate makes me like go more. Yeah, there's definitely some advantages. I feel like there's some strategy that you could build into a language though. I think what's it called, like C3 does this, or they're starting to do this, where you could do like arena. You could do like an arena scope and then do all of your allocating in here. Do like a bunch of mallocs or whatever. And as long as you never return anything from this scope, you're basically completely safe. Oh, sorry, there's another idea or there's one other issue. As long as you never return pointers from here, you won't have any like memory leaks or use after freeze or stuff like that. But you could, if this lives long enough, then like your runtime inside this one section like loops infinitely or something, then you'd be a little bit screwed. But what building system are you using? I'm doing make. I'm using TCC as my compiler because it's fast. Ba-da-na-na. Do-do-do. Okay, we also need the return type. So I guess that'll change how our parser works, because we'll do a left block. Or sorry, before the left block, we need a return type. Because it would be like this or something. So we'll do if not match token left brace, or we'll do this. We'll do match token, return token, and then we'll do return void. I guess I could use a ternary here, which I rarely get to use. How do you do these again? It's gonna be question mark. If it's true, then we want to do void. Else we want to do parser dot previous. But this is not a token. So we'll do a token void token equals. I don't know. I don't remember this function. Yeah, okay. This is a reasonable thing to do, though. We'll do a void token. Okay. We don't need to do that. Perfect. Got a two-liner. I guess we could do this, couldn't we? I don't know if I really prefer this as syntactically though. This it's kind of hard to read, but okay. Then we want to build the function. So we need to write the problem is we have to build some sort of tree to generate it. Or no, we could technically do this before the block starts, couldn't we? And then issue statements. That would save me on having to... Thank you. Okay, so we'll write the return type. Wait, we need to do output. The reason I have to pass the specific output is there's gonna be different regions. One of them is gonna be like the code output, but then I need like a section for like prototypes and type defs and stuff like that because I want to hoist everything. Whoops. Because we're trying to generate this basically int main from that. Yes, we have the return type. Maybe I don't know. Maybe I will generate an AST. Maybe I'll make some like arbitrary like array type. This is pretty close though. Int expect. don't we match though? Match left brace. Oh. Actually, this logic isn't gonna work. Because I need to actually pull it out otherwise. So else we do want to get it from the return token is that, but we also want to take it from here. We want to do a match on an identifier. Or consume. Okay. Let me get rid of this test message printout. All right, we have int main. Then we want to generate the arguments. We'll loop through the arity of the function. And I might make another string function called write args. I always do them backwards. No, wait, did I do it? Yeah, this is correct. Okay. Even looking at it looks wrong. And here we just want to do write token, or we want to pass the output. I'll just do stir. I did it again. String pointer string. And we'll do we want to do type and then name arg.type arg.name and a space. Let's do write arg list. And then we'll do a arg pointer and a length. Did it again, int length. All right, then we do the arguments. And we do arity. We also want to do parentheses though. Parenthesis for that, and then a parenthesis on the other side. And then we need to build this function over here. So this one will be, oh, this is args. Args I. Oh, it's just write arg. Like so. All right, then we've got our functions. All right, let's go to test. Let's try something else though. We'll just do x int y int. Oh, we missed the comma. I'm thinking I just do this, isn't I? I can just do we'll do this, but we'll only do it if I equals length minus 1. Oh no, sorry. As long as it's less than length minus 1. I think that's right. Yeah, there we go. So there's our function prototype generated. I don't know. I'm just gonna do add x int. We'll do a, b int. And it'll return an integer. I'm not gonna put any code in here yet because we don't have any statement parsing done. That way I can have a main function that's kind of separated. This actually does return an int technically, but expect before function body. Is it this one that's the issue? Assignment from incompatible. Oh, because I'm see, the problem is I don't know if I can pass an array. I guess I'll do that. And that's okay. Okay. Func add. What is not lint for you? Okay, cool. Now we got two, or no, this is an error. But it's for the main one. There must be something going on here. Oh, that's because because I'm matching it here. I guess we could do a P, couldn't we? And then we can pull this out later. Or oh, it's called check. Peek is pulls it or looks at the top, I think. Where was I? Oh, it was here. Okay. Check. This won't advance us, but it will check to see if it's this type. All right, that should be good. Okay, now we have blocks, which will have to have returned us a list of statements. And then we can output those. Technically, all of this stuff can be done at the very end. So maybe we'll do it that way. Every function, or if I generate the code inside of each block, then I would have to put this before. Let's just do that. Bum, 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 bum. All right, we've got our two prototypes now. I mean, I feel like if I'm pulling the left bracket out here, I should be issuing it as well. I think the block consumes the other side of it. Let's look at the block function. So here we need to issue the other side. Okay. Now blocks are fully scoped. All right, let's go to our declaration function again. Classes we're not gonna have. We'll have structs, but I'm not gonna add those yet. I guess we could. Nah, we'll do variables next. Also, statements need to be done too. What is a statement? Oh, I commented everything out on that. I'm just gonna do this for now. Okay. All right, this is kind of the old code. We're exhibiting bytecode, so it's a little bit confusing. Maybe let's actually do statements first, because statements will have expressions in them. But then we can update this one to do like A plus B. We also need return statements as well. And I also I need to update the Lexer to add semicolons, or the scanner. All right, let's do these. We won't have print statements. If statements we'll do later. Return statements we'll have to add. While statements we'll do later. These are like scoped. These are scopes. And then we'll do expression, which is what A plus B is. All right, let's do this one then. Or we'll do return statements first because those seem simple. Yeah, I do probably want this. So we need to track that somewhere, maybe in the parser. We'll have to add, I'm gonna go back and add that, I think. Yeah, emit return is just gonna issue a write output. I'm torn on whether or not I want to add new lines here. I want to add them in the wrapping scope. I think I want to add them in the wrapping scope. So I'm gonna do this. Can't return type initializer. Oh, that's for constructors. I don't care about that. I'm not gonna have constructors. Yeah, then it's gonna be an expression because there's gonna be some expression on the other side of the return statement that needs to get parsed, and then a semicolon. And then so it'll probably be something like this, write output return space, and then this will output the expression portion, which should include the semicolon, I think. Or no, I guess we'll issue it here. I don't know. No, I want to put those. I already mentioned that. I want to put those on the other side. Okay. This is where all the parsing stuff happens. Let's go to this function though. And we'll blank it out. Oh, because there's expressions and then They don't necessarily have a semicolon, but an expression statement could have a semicolon. Where was this from? Okay, yeah, that's fine. Yeah, so we parse the expression, then we do the semicolon, and I guess we'll do this. I'm gonna comment that out for now. Okay, so this is bad because we want to do the wait, where is this thing? There might be a space there. Yeah, there we go. We'll do a new line here just so the block's on the next thing. All right, we have a return. We just need to print out the expression that's going to be inside of here, which is going to be a plus b. So we have to parse the expression with the prat parser, and then we can emit it along the way. Thank you, Lavender Loot, for the follow. Appreciate it, man. Welcome. Welcome, welcome. All right, so let's go to block again. Let's just walk through this. Yeah, this all seems fine. For each one of these, though, we do need to parse a declaration. Function declaration, which will be a statement for most cases. And most of the time it's gonna be a return statement or an expression statement. So we're doing return statement. And we've got that. Blank return is just this. The new line will get added elsewhere. This, though, is going to be expression. Yeah, this is going to be a little bit complicated, but we'll get through it. This is all the prat parser stuff. Parse precedence. This is the like the rule table for the prat parser. There's going to be a bunch of different cases we have to go handle, but we'll kind of get through them, I think, one by one. Type defaults to int. But I understand. Oh, because parse rule isn't defined, I think. See, he's got some pretty bad I'm just gonna undo all those. Yes, we have to go and comment all of these functions. These are all the prat parser ones. I might throw all of this into its own file. This is like a call. That dot is definitely in there. I think literal's in there too. Argument list. Oh, this is for calling. Yeah, we got the unary we want to add. Oops. Binary. Let me just go upwards. Oops, I went downwards. I don't think that's part of one. String. I don't know if I need that. Number, I think I do want. That'll turn a literal, I think, into a number. Binary. That's for binary operators. What is this variable? It's a token identifier. Okay. Initializer. Wait. Oh, string. Or token string. Oh, element is not constant. Oh, this is the problem. This is a type. We've got literals. I'm gonna do null here. Null here. We'll do this maybe. Oh, I'm missing one. I'm also currently working on a compiler. I don't know anything about parsing until yesterday. I think I used shunting yard to get into RP and then build a tree from that. Oh, interesting. I'm not sure what shunting yard is. But that book that I mentioned, Crafting Interpreters, has a really good explanation of parsers. The algorithm to convert infix expressions to postfix. Oh, interesting. Okay, that's cool. Yeah, the parser doesn't seem that complicated. The complicated part is filling out this data of like priorities and stuff. But I think the loop isn't that complicated. You just like choose which one to parse, or like choose when to like go in another nested level depending on what you see next. So yeah. Variable. It's hard because I'm adapting this from bytecode generation. Oh, this is not the one. It does seem a lot simpler than what I did. Yeah, the nice part about it is you can take all of your tokens and have like one area where you decide what function you call, depending on if it's prefix or infix. The left one's prefix, the right one's infix. And then you have a precedent list, which is just an enumeration that helps you determine like the priority. But yeah, read that book. It's a long book, but there's the second half is all in C. So you can cut it in half and just do the C side. But if you're interested in languages stuff, I recommend it a lot. Highly recommended. All right, this identifier function pointer is going to get called. Where is it though? I thought I had one. I mean, it's called variable. Named variable. So this resolves the scope of the variable and decides where it needs to get it from. So if it's a locally scoped variable, it gets it locally. Otherwise, it gets it from the closure. Otherwise, it gets it from the global. In my case, though, I don't really care right now because I'm not doing any semantic analysis. So I just need to does named variable get used in other places? I'm just curious where else this gets used. Variable, named variable. This is all in super. Oh, it's all in methods. I don't think I need this. But essentially this is like I'm pulling out an identifier. Why does it go to variable though? It's weird to have the rule table? Rules? So whenever I encounter an identifier, I go to this variable function, which is strange. But I guess it's not that big of a deal. I mean, the emission for this is super simple. It's just write output. It's actually write token. We just want to write the token. What if I simple get rule? Oh, I thought maybe I accidentally undid that change. Yeah, so it's doing return A because there's no binary operator yet. Because the original code is A plus B. So we want to go to the binary one, which is this one. Let's uncomment that. We'll have to read that book. I have something similar to the table you just showed, except it contains a number, which is the priority, and whether it's left associative or right associative. Oh, okay. Yeah, yours might be very similar to parsing then. Can parsing deal with things like ternary operators easily? I haven't done a ternary in it before, so I'm not sure. I'd have to try that. But I gotta imagine it wouldn't be that hard, because what is it? It's just condition. This would just be one expression, right? Yeah, I'm not sure. Yeah, I could see. I don't think that this would be too hard to do. I haven't done it, but maybe I'll try to add one to my little language. I do kind of find ternaries a little bit symbol soupy sometimes, but okay, so we get the previous token, we get the type, then we'll use that type to switch on it and do different stuff. He does this emit bytes function, but we're gonna have to rewrite this to like emit operator or something like that. Yeah, and then this goes to parse precedence again. It gets the rule, then it does this. Perfect. So just the emit bytes part, we need to change that. I'm gonna comment those. I'm gonna do this. OP equal, OP not. Sorry, I'm just thinking here. Oh, I know why that is. This is, I was like, why is it adding two of these? But it's adding the equal and it's adding the not for bang equals. So for the VM, it does an equal comparison, then it does a not on that. So for us though, we just need to emit the, we just need to do this. Let me do one really quickly, hold on. Right. Because we're just generating C code. This one will be right. I'm gonna copy this in my buffer, hold on. Or I guess we'll keep them around. This one's greater than. Whoops, I just did less than. That would have been a bad bug. This is greater than or equal. Less. Less than or equal. We've got our plus operator, minus, multiply, divide. Boom, 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 boom. Binary. I don't know why this does it this way though. It does BA plus, which makes sense in the stack ordering of things. Yeah, I guess I don't recall where this gets called from. How? I'm not trying to replace a string. Yeah, so it sees the plus and then it goes into the binary, but it's already on the left side, I think. What? Oh. Yeah, so the problem is it's doing the B before the A. Yeah, so when we do binary, we actually want to operator type, rule precedence, first precedence, rule. Do, 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 do. Do, 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 do. Sorry, it's a little bit of a recursive mess. Let me get some water really quickly. I'll be right back. All right. We have water. Boom, 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 boom. think those are correct. Previous. Rule. I'm just trying to understand what get rule based off the operator type. Oh, that way it knows the precedence. Oh, that's what it's for. And then we parse the next expression. Okay, let me parse the next expression, which is advances. Gets rule based off of a variable. But the thing is, a variable is a prefix rule. So it sees it as a prefix rule, and it calls that. What I might do is I might have these generate a tree, an expression tree. I might make these generate an expression tree, then just walk that tree. Because otherwise I'm like interweaving all these little like printout statements in every single one of these things. I feel like it's just easier to have an expression tree. I think that makes sense. So let's do that instead of this. I will leave this because this is probably gonna come in handy later on. But it'll have to be something more like this. Let's go to the top of our parser. We'll make a new struct that's going to be type def struct, and we're going to call this expression. It'll have to be a tagged union, so we need an enumeration. How do you do these in C? I think it's in here. Yes. Expression type. And then we'll have to do a where did I use unions in this before? Or sorry, tagged unions. Yeah, it's this. Then we have all the types we want a union on. This is how you might do an AST, but we'll just do it for expressions. It's hard because it's like, I'm gonna do this. And we'll do a type, which is, this will be, and this will have a left. Of course I do this backwards. Left, left, expression right. And they'll do an operator, which will be like whatever this thing is. Oh, I thought, yeah, I guess it'll just be a token type. I don't think I necessarily need to do, like, what's it called? I don't think we necessarily need to do, like special operators. We'll just look at the token. Okay, this will be the first one we do, expression binary. This will be, or do I do a list here? I don't know, probably. we'll do that. Okay. Okay, now we can go to our binary. Oops. I'm searching for a file named binary. Okay. Let me look at this function. I didn't super deeply think about how this would work, but I did kind of figure that this would be easier to deal with. Yeah, we look for prefix rules. If your precedence is less than assignment or equal to it, we check that, and then we do the prefix rule. So that would be like A. A, which does a variable. So I'm just kind of walking through this, which all it's doing is writing this. So that doesn't return anything. I'm actually wondering now in my head, how is this going to expand? This union thing as expression binary. Isn't that an infinite loop of struct declarations? Because every expression binary needs to fit the size of itself inside of itself. So these need to be pointers. Yeah. Yeah, otherwise the size gets recursively added. Or all the things in here could be pointers. Maybe that's better. Make each of these a pointer. Yeah, I think I prefer that. Okay. Because then these can just have the data in them. I think that works. Okie doke. I'm just trying to think of how this comes back. Like, what does this bubble back to? Because it's very like linear, not like recursive descent where it's like I have a clearer picture in my head. So we do a variable rule here, which calls the prefix rule, and then after that we loop. Yeah, while the precedence is less than or equal to parser current type. Get rule of the current one, like the next one, which is going to be the next one. We advance. Then we look for an infix rule where we'll find the plus sign for binary. And we'll call that function for the binary one. The binary one calls back to this to get the right side of the binary equation. calls back to this, which where it'll find a prefix rule as well. So really, I think if this returns, I just don't know what it would return. Like in my head, like this should return an expression. Like this should return an expression, and then this would return an expression. I just don't know what it would return it from. Because that's when we do a prefix rule. Boom, 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 boom. Boom, 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 boom. Here the parse precedent can take in a pointer to an expression, recursively add children. That's true. So then for binary, it would. Sorry, my music messed up. Do, do, do. What was I saying? Okay, so if I get a prefix rule, like this could return back. I'm just trying to think, like, for example, if this is a variable, then I can go, or if it's an identifier, I can call the variable rule for the prefix rule, which would return back probably an expression type of like, or something like that, you know? So it's going to return back one of these. But then when I call the infix rule, I guess I need to pass in a left side, right? So I need a function pointer that can receive a left side. Because if it's an infix, it's got to be a binary, doesn't it? Or I mean, sorry, if it's a infix rule, it's got to have a left and a right side. But I've already parsed the left side, so I need to pass that into here, I think. And then this can parse the right side. So when we go to this binary function, we're going to call parse precedence to get the right side of the expression, because this has to return that. I think that makes sense. So I think for infix rules, we pass the left side in explicitly, but for the right side, okay, that's a little bit of a rewrite, but I think this is correct. Because this does seem like it would return an expression, right? Or does it return a pointer? No, it doesn't return a pointer. But wouldn't that mean I need to pass the left side here? Hold on, let me walk through this again. No, yeah, I think that this is going to work, because this is going to return like the right side. It'll be like expression right side equals this. And then each of these is going to be, like, for example, this one's going to be, let me just do this. Man, I hate C switch statements. Can I just do this? It will be return I guess I would return expression, huh? Did you consider providing a resell license for your engine? Not really, no. Most of it's open source, or a lot of it's open source, so you're welcome to use it if you want. You can use it just for free. So the left half needs to be passed in. I'm just gonna go ahead and call this right. The left would have to be passed in. Then we have the right. And then we have the token, the operator type token. It's funny though, because I don't need this switch statement at all, do I? I think I can just do this. Operator, or sorry, parser. Or hold on. Op token. I don't think I need this switch at all anymore. We'll read the op token because we're just trying to return a binary expression. Oh, we want to return an expression just so I can build the type stuff in it. And so we need to return. We'll do expression return equals. I think I can do this. And then actually I have no idea how to do that. Would I do this binary? Like I don't know. A neovim enjoyer and more like an Emacs enjoyer. But yeah, something like that. What is licensed MIT? Yeah, most of my code is MIT. I think I have some like Apache license code. What's up, Da Vinci? How's it going? But the finished game won't be under MIT with sorts available. No, it will not. I don't remember how to build unions in C. How to build a union in C. I'm so glad that there's AI now that I don't have to go to Geeks for Geeks website to look at syntax for stuff. Oh, I do this. Let's just do this. Hold on. We'll do return dot type is binary. There's probably a faster syntax than this, but I just don't know it. And then we have return dot binary is going to be equal to expression. This needs to be heap allocated though. Is there a way to I'm trying to think of what's the fastest or what's the easiest way to just like allocate a blank or a block of data like this. Can I just make like a custom malloc function that when I do the same thing as you with Zig Live, I'm going to be thinking of this. What's Zig Live? Bum, 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 bum. Oh, with the Zig language? Oh, okay. Yeah. Hopefully my suffering can help you. I just want to like I want to allocate and initialize the struct. There's got to be a way to do this, or at least, or maybe I do like a void pointer or something. I don't know. Like I know I can malloc a blank struct, or not a blank struct, but I can malloc a struct and then set all the fields. But is that how people do this? Yeah, I guess you do. Huh. How else? Yeah, that's what that's what I'm looking online for. I'm hoping there is another way. All right, I guess we do this. Or hold on. So we need this to be heap allocated, so we have to do expression binary, malloc. And I think I can do. Does that work? Semicolon got expression. Oh, this is not defined. That gets me so often. Oh, I need to hoist one of these or both of these. I usually write basic things myself first, which I know I'll need, then use it as a foundation for more advanced stuff. I just updated my commercial license starting at $20 a month, and I have this organization revenue scaling, so 200 then 2,000 a month if you're flush. What do you think that's fair? I mean, it just depends on what you're offering and if people are willing to pay it. But if people are willing to pay the price, then I guess they thought it was fair. What is it? Didn't I do this? I can't remember this stuff, man. It's been so long. No, do you do like this or something? Or no, you just... Oh, type def struct. Or something like that. Or maybe you... I know I've done this before. Ah, there it is. And then you can just define it like this. There we go. Okay, perfect. So we'll type def the expression, and then it'll be hoisted, I think. Field left has incomplete type. How could I possibly do this then? Oh, because I need... Like, how can I complete this without, I guess maybe this one I need to hoist then. And then I can do the expression above the expression binary. Because it's a pointer, so it's a known size. Oh. Oh, whoops. I need to do this. Operator type undeclared. Oh, this will be op token dot type. What kind of language you have been? I'm working on myself. Which is why I tuned in. I'm just kind of messing around. I just finished reading that book, Crafting Interpreters. So I'm kind of like adapting the code to something a little bit more custom or that I like. And yeah, we'll see where we go from there. I have a few ideas of what I want, like the features I want, but it'll be like a C-like, Zig-like, Go-like language. One thing I will say though, the C errors are just awful. Oh, I bet that this function is has the wrong return type now. It returns an expression now. Yeah, I don't think this is gonna work. In how to, would you just do like, do I have to call like memcopy or something stupid? Or can I just do this? How to, or maybe I can do this or something. Left undeclared. Oh, left needs to be passed in. But for now, I'm just gonna do this. I'll just put it up here. I'm just curious if it'll compile. Cannot convert struct anonymous to enum anonymous. No, yeah, okay, that was right. Struct anonymous to enum anonymous. I'm just gonna manually set them. Or actually, it's a pointer. Left, right, op token. Oh, it's .as. That's what it was. Oh, so then the other way might have worked. Let's copy this. We'll undo. Oh, actually, that was it. Expression.as. Field not found. Oh, that's a binary expression. So it is actually just this. Pointer expected, yeah. You don't think I need expression binary? Wouldn't you think this should work? Well, now I'm all messed up. I have a binary expression. Maybe I'll just do this for now. I'm confused though on why this is to enum anonymous. Oh, token. This should be a token. This one is the one I was confused on. I need to return something. I think the union need to access the name in the union. Yeah, for some reason I thought, because I wrote this as EXPR and I thought it was expression type. Really, I should probably have a better name for that. Yeah, so now we have this. It's crazy that's just a warning. This needs to take a left and needs to return an expression. Well, technically only the infix ones need to take an expression, take a left. I was just about to start designing my language and this live stream popped in my feed. Nice. You should check out Crafting Interpreter's book. It's pretty good. But this is technically correct. Let's go ahead and... Would I ever have a left? Because unary is always going to parse and then do a right side. I completed it 2 days ago? Nice. I completed mine this morning. I'll make a separate parse function infix. That takes a left. Expression. Left. And then who defines this? Or that is the, oh, okay. I see now. Now they're all wrong, perfect. I wish I could just do something like this, but I cannot. What am I missing? Oh, this one doesn't return anything. Statement is going to return something different. Declaration is going to return something different. All right, grouping now fits, compile call. Takes an expression, also takes a left expression. X. Dot. Turns an expression, takes an expression, left. Have you named your language yet? No. Might just do this. Expression left. Expression left. Unary. That one's done. Well, that would mean binary is wrong. Oh, this one was missing the left. This is the only one we've implemented. All right, that was a big chunk. Binary's done, unary's done, or hold on. For some reason it thinks unary is bad. Oh, because this is a prefix, so it doesn't take that. It just needs to return something. I'm just gonna go make up one. Well, we'll have to go back and fix these individually, but I just want to get the framework in place. Variable. This was a prefix, I think. We'll have to build that. This one's going to be parse string. Parse number. Oops. I'm gonna copy both of those. Okay. This is an infix, so we need to pass a left in. We'll also just do the or while we're here. Okay, we got literal. That should take out a few as well. Literal, which is a prefix, so it doesn't take a left in. What's up, WRKR-TV? How you doing? All right, this might be the last one. Oh, it's a prefix, so we just do this. Pronounced worker if that's easier. What are you working on? Oh, nice. I just finished that book, Crafting Interpreters, so I'm kind of like expanding on that and like rebuilding his code into what I want to build now. I'm just doing like a little programming language pipeline, I guess, for a compiler. We've got the tokens done. We're now doing the parser, and eventually I want to generate C code, both C code and then also bytecode. So I'm kind of compiling to an AST because I want to statically type my language. Or I'm technically not generating an AST, but for the expression section, I'm gonna. And then I'm gonna emit blocks, code blocks in C, and yeah. What are you trying to build? I have a few ideas for like what I want out of a game dev language. So I'm trying to like build all those concepts into one thing. I know there's alternatives, but I'm just kind of exploring. I'm not like doing it super seriously, but it's more of just like a learning thing. But if it pans out, it'll pan out and I'll be happy, all the happier for it. Shoot, I don't know what I was planning to return from here. I don't understand any of this, but I've been trying to learn recently. Yeah, you should check out, or if you're trying to learn programming, it might be too hard of a book, but there's a book called Crafting Interpreters, which is free online, which explains a lot of this stuff. I feel like I had in my head some way that I was going to do this, but now I cannot remember what it was. Because if you do an infix rule, that's going to return back an expression. Like you parse a prefix rule, you always parse a prefix rule, you'll always get back an expression. But then if you parse an infix rule, then this becomes part of that one. So I think you'll do this. And then by the time, once you eventually hit the end of it, then you know your expression's done. So I think we should return an expression like that. Oh, return. This is like a failure case. What I might do, I might make a global like blank expression. We'll do this. Where's my expressions? Wait, I guess that. I'll just do, I think globals get initialized to 0, don't they? Thank you, buddy. Good luck with yours as well. We're going from a game dev direction, so I've been starting with GD script. That's a pretty neat course on it that's interactive and stuff. Nice. That's a good place to start. It's made for someone who's isn't particularly technically minded. That's cool. It's cool. That's a good place to start, it sounds like. Get rule. Oh, parse function infix, I think. Hold on. Yeah, let's call that. This needs to take a left though. So this needs to take the expression on the left side. Oh, this needs to return. Oh, we just return this. Voila. Whew. Well, I think it's parsing, but we need to make sure it's going to output stuff because this is just function headers and then this is just function headers. So we have that one a plus b expression that we want to output. So now that we're there, it should be a statement, right? Which should be a return statement, which then calls an expression. So when we're emitting the code for the return statement, I think we can emit the expression as well. So we'll do, I might make a function that's like write expression. Then all the statements will just be outputted because statements are pretty like individual. All right, let's go to our write functions. No, I have some in here. Here we go. Void write expression, string, star, string, and then we'll do expression. I'm actually starting to remember to put the type before the name. Crazy. And then the order is already a part of the expression tree, so it should be easy to just, oh, also we need to parse the identifier ones because we don't have that yet. I don't know if C has the exact same precedence I want, so I'm probably just going to do grouping statements for every single expression. But we need an identifier expression as well, which might just be a token type, but we'll see. Let me think here. Let's do the variable one first. Yeah, here's the binary. We need to do something very similar to this. Or actually, this one we don't need to malloc anything. We can just do we'll just do a token expression. Or actually, I'm not even gonna make this a thing. I'm just gonna do this in my union. I'll just do token, and if the type is an ident, then we'll pull out the token. So we'll do, then the expression is gonna be this. Expression equals, I can't remember the union syntax, hold on. It's gonna be, yeah, expression return, expression ident, and then not as binary, as token equals parser dot previous return ret. So if I understand correctly, you're building a language. How far along are you? I'm doing the like AST parsing right now. I followed you on GitHub. We'll test out your language if it becomes open source. See ya. All right, buddy. Thank you. See you later. Are you planning to port Mythfall to your new language? Not really. If I end up being happy with my language, it's more like it was something I wanted to learn, and so I learned it. And then now I'm kind of like curious about like edge cases of how you can build programs with certain sets of features in a programming language, you know? So I'm kind of interested in like exploring that a little bit. So I might do like a few like game jams or something, like one-day game jams where I try to use this language and see how they do or see how it does. But I think Mythfall is too far along now to rewrite it in a different language. But the language's syntax is probably going to be very similar to Go, so it wouldn't be like an impossible port. It would be very difficult though. It's more just like something I'm going to do like one day a week for fun, for funsies. You do game dev as well? Yeah, I primarily do game dev. I work on this like bullet hell MMO called Mythfall. Expression equals expression. Oh. Okay, then we have our write expression function. I think I did variable. Yeah, what did we do? We made an identifier, we passed the token to it. And yeah, cool. An MMO ambitious, respect that. Yeah, you can play it in your browser if you go to mythfall.com. There should be a link somewhere. I can definitely see why, yeah. There's just a few issues with Go, which made me want to explore this a little bit more. But yeah, rewriting at this point would be a lot of work. But I'm always interested in learning, so that's one of the downsides of working on a big project is you get past a certain point where you've like learned a lot of what you needed, and then it gets a little bit more tedious, which I think is why a lot of people give up on projects, because it gets to the tedious part and then you're like, I don't want to do this anymore. Like I've already figured out how to do it. Now I just need to like add a bunch of content. But I want to see Mythfall through and see how it does. Yeah, I mean it's a pretty small MMO. It's not like a it's not like WoW or RuneScape or anything like that in terms of scale. That's cool. Yeah, if I had to start over, I would have started on smaller projects, 100%, 1,000,000,000%. So I highly recommend doing that. But as always, you get a little bit too cocky and then you make a lot of mistakes. Okay, this is the output string, and then we have our expression that we want to do. I think all we need to do is we need a switch on expression dot type. I guess I need parentheses for this.
And then we'll do case. On these two, these are our two options. Okay. For binary, I really like your sprites. Did you create them all from scratch? I started with an asset pack, and then I slowly migrated over to like an art style that I like. And I had an artist who worked with me a little bit to like get started on some of the shapes. So that helped a lot because now I can take shapes that were already made and then just kind of adjust them to what I need. And then I've learned over time how to draw stuff on my own. So I've gotten a little bit better over the period of development. But yeah, art is pretty tricky, but I'm glad you like it. Because sometimes I look at my art and I'm like, man, this looks terrible. Just because I see it so much, it's like kind of, you get desensitized. My first game was just an if. Oh, an IF. Now I'm graduating that to a Shadowgate style point and click. Ooh, that sounds fun. I think you did it right, MMO first boom. Well, I've worked on other games before, but like back in college. I'm very interested in like network programming and like lower level stuff like that, I think. But I'm also interested in like a little bit of gameplay programming, so. It's tough though, because it's like, I really enjoyed the path that I took to build Mythfall. But now I'm at this point where like, I wish I just used other people's libraries for certain things. But like I learned so much, so I can't really complain. Because I don't want to give that up, but also I don't really want to use some of my libraries that I've made. Like my rendering library, I don't really want to use that, to be honest. So I'm like stuck in this like weird thing. All right, this will be write token to the string with the expression dot as dot token, I think. I like your Nitrix for the 30 bits, buddy. Something hindsight, right? Yeah, true. I mean, that's why I think it's good to do small projects, because then you can experiment and learn stuff. And then if you want to do a big project, you've already built up a foundation, you know? Yeah, you'll always regret stuff in life. Even if you do all the right choices, you'll still regret, I think. So there's not really any way out of it. Just don't even think about it. I would have used Comet Stream though. What's Comet Stream? I should have started doing this in my 20s, but here we are, yeah. True. I'm also in my 30s. Or I'm also out of my 20s, I guess I should say. Okay, so this one is recursive. We basically want to do, as we know it's an infix because it's a binary operator, so we'll do the left side, then the operator, and then the right side. So it'll be write expression, string with the exper.as.binary.left. And then we'll do write, and then in the middle, we'll do token. Or it might be .op, I think. All right, let's see where I messed up. Expected struct or structure unit expected. All right, let's reference expression .type. That should be that. Oh, this one's a pointer, so we need to do arrows. This is one of the first features that I think C should have got rid of. Oh, look at that, A plus B. We should be able to do all sorts of math that now. I also want to do parentheses for these, hold on. Oops. Like we should be able to do this times 5 minus, actually the 5 and 6 might not work. Times C divided by D plus E minus A. Uh-oh. Oh, not write token. This is just write. Right. Look at that. We got our precedence parsing, operator parsing. So look, I did it in Java 25 years ago. Still a viable platform. Chunk packets over HTTP. Yeah. Java has a pretty big legacy. it was a pretty like major impact language in my opinion. Even though I'm not a big Java fan, I can't talk bad about it too much because of all that it did for programming. Cool, so we've got operator parsing precedence, though a lot of things are going to be missing right now because we only handle binary operators and identifiers. So let's go through and add all the rest of them. If I was a wise man now, I'd start adding like unit tests. Actually, no, we're not gonna add a unit test till we bootstrap it. That's right. Like if we do a -5 here, I think it's gonna like minus, and then it doesn't know what to do. I might do a default. It's hard to see because there's no like stack trace panic features. Can I just like dereference a nil pointer and get my stack trace? Is there a way to panic in C? Or assert or something? Assert in C? Sorry, I'll look here. Asserts in C. Right, tutorial point. Expression. If the expression evaluates to false, what if I want to pass a string to my assert, sum not greater than 5? Assertion path. Can I do wait, which way was it? Okay, it was that way. Oh, so you can add your message like that. Okay, I have an idea. We'll make an assert macro. Assert only debug builds. How do people do? How do you just like? I just want the stat. I just want to panic. Like, would you do an assert for that? Static assert. C11. I don't know if I support this. It's in assert.h. Implicit declaration of static assert. Yeah. Assertion failed. Oh yeah, because we had that in our test. Hold on. R. Now it's exceeded because it never got to this thread. I'm gonna go ahead and just in my main. I might just do like a two arguments, condition and message. Yeah, assert doesn't support that. My compiler is not C11 though. It's like C90 something. It's like C98 or something like that. If only I knew how to write macros. Define, assert, im, assert 1 equals 2. I think that's okay. Okay. Oh, let's do 3. Cool. I like that. See, in modern languages, they just let you, they just force you to handle all your cases. However, C does not. Actually, Go doesn't either, so I usually just panic. But this will be fine for now. All right. Numbers. Let's go to our rule table. Rules. And we have what? This is actually a cool C feature I didn't know about, that you could assign indices like this. That's handy to know. So much text. The most text ever. What were we doing? Oh yeah, we were gonna do number. We did binary, which is a big one. Variable? Oh, we did variable as well. Let's do number. Consolidation. Yeah, that's how you know it's efficient. This one's also going to be a token, but it's not an identifier. It's going to be a literal. I think I'm just going to reuse the token field. Oh wait, literal's there though. What is number for? Token number. Maybe literal's for strings? Oh, false, nil, and true. I see. I asked this question with humor intended. Why do all game engines break doing simple things? Yeah, I have no. That's a good question. If I had the answer to that, I'd be a multimillionaire, maybe even a billionaire. What are you? What game engine are you using? One thing I will say is backwards compatible serialization is pretty tricky. So if it's something like your file got corrupted because you upgraded your thing, I could see that. Unity, yeah. Have you used it for a while? What's your opinion on the runtime fee thing that happened, the fiasco? Yeah, quite some time. Were you deterred by the runtime thing that happened? I remember that popping up. That was like a year ago. I'm so poor I don't have a say, really. Damn. That hurts. I get it though. Like it's like it doesn't affect me. Okay, we want to emit. The thing I don't like about this is, I guess we'll just do a synthetic token. I mean, out of the metaphorical troughs of society. Dang. That sounds deep. That sounds deep. I know there's a variable function. Oh, here it is. Do I make a function? It's funny because all of these are going to be the exact same thing. I'm going to make a token expression function. Token expression. And we're just going to do this. Ret, this will be the type. The only difference is that this is an identifier. But then when we go to number, this is just going to be a literal. There's also one that is called literal. Literally. I think I just do this. False, nil, true. These are like keywords, basically. I don't know if I'll keep it a literal. I might keep it a, Why is it called literal? That doesn't make sense to me. When I think of a literal, I think of like what he has in number. Whatever. We'll use lit. I used to write 2D games in browser with TypeScript, and I feel like I could do 10x the thing Unity can. And Unity streams. And Unity streams on Switch, but they only care about displaying stuff, not answering questions. Oh. Why don't you keep using TypeScript then? Like if you feel like you're more productive in TypeScript. I just felt like whenever I used Unity, I felt like I was always building like a custom script for every single thing. And there was not like I didn't feel like there was a good way for me to like reuse things and like build systems and stuff. I can't author a TypeScript game really. Oh, okay. And distribute it. You have to like distribute a Electron package probably. Cool, we got our new identifier failing. Look at us dynamically panicking. Literals were just also emit. Then we got our -3 is there. Or the rest one, I believe, and then I can't even get polished, and then your browser would have from Chromium. Yeah. Oh, is there a Rust version of Electron? Eggs and toast ready, nice. All right, so we have our add function, which actually kind of works. But it doesn't actually, it's not valid, but. What other syntax do we want? Let's look through our rules table. Or hold on, there was something that I was forgetting. Oh, I wanted to get rid of this syntax. Now that we have, yeah, it should expect this, but we're gonna add to our scanner the ability to not use semicolons. Skip white space, scan string. Oh, that's for comments. I don't think I can put this here though. The comment section, obviously we wouldn't have white space, or sorry, we wouldn't have a semicolon. This one's in, who calls this? Maybe that's what I need to look at. Scan token, skip white space. Oh, it's just skipping to the next token, basically. So if you, I guess if you had like something like this, bar X, then you might have to do one right there. But inside of a comment, it's not a big deal. Scan string. What we'll need to track what our last. Oh, this is for multi-line strings though, so you wouldn't do a. I see now. This is for multi-line strings, so we would ignore this because this is so you can have one big string. Okay. So this is the only place we do this, I think. So when we find a new line, we basically want to have in the scanner some knowledge on if we're inside of like a statement or if like what the last tokens were that were emitted. Like if we need to add in a semicolon automatically before we line plus plus. Where's the scanner type def? Oh, this is in the wrong one. Of course, I opened it again. Scanner. There we go. Okay. Wait, isn't there a previous? How do I get that? I thought in my parser I had like previous. Well, that's in the parser. Okay. I'm just gonna do like a prev and I'll make it a token type. I'll do last actually. This will be the last token type that we scan. Which I think when we call advance. Maybe it's scan token is what we use. Yeah, as the parser is looping through, he's just getting the next token. Okay. So I think what we want to do is skip white space should return or could return a semicolon. So here's what we'll do. This will return a Boolean, and if we're here, we're going to do return true. Yeah, we'll just do it for now. I think we'll eventually check to make sure we want a semicolon. Yeah, so this will return true if we want to insert a semicolon. Then all the other returns. Return false, return false. False. Fossil. False. There we go. Okay. Add semi. This is like a fake ad. So we'll just do isn't there one that's like synthetic token or something like that? Parser. I'm gonna put this in here. In the scanner. Excuse me. Ooh, it always comes in pairs. Okay, so if add semi, then we'll return This doesn't really do what I want though. Talk dot. Let's see here. Oh, whoops. Talk dot type equals token semicolon. We'll return talk. We'll build this every time, which is fine. And then we return it. The only thing we need to do here is we need to track if we want a semi on the scanner. Really, we'll do this. Scanner dot. We need to add a field though. I'm not gonna. Do I want to add last, or do I want to add like a Boolean? I could add a Boolean that's like, oh, we're on a line that needs a semicolon. Actually, I don't know if I can really parse that. It's really about what the last token is. So really, we'll do this. Return scanner dot last equals something that is a semicolon. Hi, I'm learning JavaScript. Any tips? I don't really know JavaScript, to be honest, so I don't have too many tips, but I know it can be kind of a confusing language. But yeah, I think in general, my tips are to have a project you're building and then build that thing. Don't like boil the ocean, try to learn everything. Like, I think focused learning is better and more applicable too. But let's just like look through this and see what after which tokens, when we see a new line, we want to imply a semicolon. It's like after identifiers. So if it equals after a right parenthesis, or maybe I should make this list. Really, if I was slick, I could probably put them in different ranges. Like, we'll just do it. I'm just gonna make a function though. Return return check implied semicolon. Okey-doke. And then we do scanner.last, and then we just return return talk equals right parentheses, oops, or right braces. I don't think we need them. Comma, we don't want it. Dot, we don't want it. Minus operators, we don't want it. Bang equal, these are operators. Yeah, these ones we all want it. It might be better to just do like a lookup table. And class else false. False, we would want it. This is like a keyword. Like you could end a line, like return false, for example. Which means we'll also have true. True. Return var while error. That might just be an invalid one. Oh, token. Yeah, this is fine. Scanner last token type. Function pointer expected. Where? Are you making an app? I'm making a programming language today. So not quite an app. Do I need to parenthesize this entire thing? Where is it expecting a function pointer? That's what I don't understand. Oh, I might not be able to use static because it's a... Oh no. You're missing a... Oh, you're right. Thank you. Glad someone's paying attention, because I'm not. Unexpected character, unexpected character. Scanner.start. These are pointers though. Yeah, so we should see this. But then the next time we come through, we shouldn't have any white space, so it should just return false. I wonder what the token list looks like. Maybe I should be printing that. I'm just curious how the tokens get like produced. Printf. Can I do... No, I can't just print this because it's print the entire file because there's no null terminators. Let me just see. Maybe I can figure it out without doing this. Let's see here. Oh, I'm not tracking what the last token is, so this will never work. Okay. So when we do scan token, that's hard because we just return them out of here. Let's see here. All right, we'll just simplify it. We're just gonna do this stuff like this. And then we'll do scanner dot last equals ret. Or do I do make token on everything? Make token, identifier calls make token, scan network calls make token, scan string calls make token, scan token calls. Yeah, okay. Okay. That one we checked. Identifier, let's look at that. That recalls that, yep. Scan number. Yep, that calls that. Then all of these call make token. Make token, make token. So I'm just checking all the return places. So scan string also calls make token. All right, we can just update make token then. make token. And we'll do scanner dot last equals token. Scanner, wait. Oh, token is type. I'm just gonna throw this up here. Line 2, unexpected character. Oh, it might be issuing a semicolon in the gaps. Like, I think there's one for here, 2, 3 in each of these gaps. Like, if I delete all these, does it work? And there's just one, maybe here. But it is getting the semicolon, or it is parsing this one okay. Line 2, oh, it's this one is the one that's failing. So it's not getting the semicolon. It's not getting the semicolon for right parenthesis. Token right paren, okay. Unless I did these backwards. No, okay. I'm just gonna print out the number. Or maybe I'll do it inside of scan token. So we're calling scan token. I'm just gonna do block.type, or sorry. Something like this makes sense too. Nope, not talk.last, it's scanner.last. All right, let's dump these as they come through. %d parser dot current dot type. Whoops, I need to do a new line. 38. 0, 1, 2, 3. Am I really gonna count these? 4. I'll just do token EOF. Can I just make a global array like this? String. What do we do for the rules? Rule. Parse rule. Yeah, I want to do that, and then I want to do one for each of these. Well, let me just get these organized. I'm going to do a macro for all of them once I get them all on the same line. Oops. Okie doke. All right, macro. I'm gonna copy this. Left bracket, right bracket, space equals this, that, start there, and oh. I don't know if I need to do the braces because the other one's a struct. Defaults to int. Oh, this is that right? Are you an array of these? How to make an array of, and see. Oh, man, my brain is so warped by Go. Huh? There we go. All right, so let's go to our parser, or where we scan token. Instead of printing this out, we'll print token name. We'll index into that and get the token name. There we go. That is a lot better. Then we don't have to count. Oh, we admit a token error here. That's wild. Okay. But yeah, we have a token function keyword. Then we've got an identifier for add, left paren, identifier, comma, identifier, right paren, identifier, left brace, and then a token error for some reason. So let's go to our scanner. It's after this one. Make token left brace. Error token, unexpected character. Well, it's weird because what could the character possibly be? So you're creating a programming language? Yeah, working on one. After the left brace, sick stuff. Yeah, it's fun. It's makes you think a different way than a lot of other programming tasks will do. So I guess skip white space would get called, but we wouldn't find a new line. We'd find a space, and that should just go to advance. Oh, scan advance is going to push us past, isn't it? Add semi equals this, spool that. Okay, the error is still there though. For some reason after the left brace, it's for some reason after the left brace, it doesn't know, like none of these are returning. Unless I like, maybe when I was undoing, I accidentally deleted a return statement. Yeah, like nothing's returning, so it's not able to understand what the token is. So that's not good. Left brace. Whenever we make a token, this will be the last token that we emitted. Just a little confusing as to why. Like why after doing this? Well, after doing this, it finds the new line though. Then bool add semi. Scanner advance, then we return add semi. This should return false though. I don't know if you can, I guess %D, because I think it's I don't think there's bool types in C. Can I do this? Oh, I'm gonna do a /n. Yeah, add semi 0. So it should be a false. Oh, actually this kind of, because there could be more white space after this. Wait, but then wouldn't it come back into here? Yeah, I think what's happening is this is returning false, but the white space has been captured. So really we want to do this if, wait, but we capture all the white space to the new line. Oh, but this returns false. So then it doesn't add a semicolon, and then it finds the next one's a space there. And that's the unknown one. So we only want to return here if add semi. That's the only case in which we want to return there. If we find a semicolon, then we want to return that, because then this scan token is going to return. And then the next time we enter, we would skip white space at the start. Cool. Let's delete this. And then in our parser, I'm gonna go ahead and what is it? Or it's like a scan next or something. Yeah, I'm gonna comment this out. We can do indentation pretty easily, but we need to know if we're in a block scope first. Well, this is a pretty good starting point. I think I might end stream here though and go eat some lunch. But yeah, it's coming along. We can at least emit a little bit of C code. But I think we've got the expression parsing. We got the parsing framework stuff in place, I think. Minus some of the statements and expressions are probably going to be missing. But yeah, we're on our way. But anyway, that's going to be it for everyone. That's going to be it for the stream, everybody. Thank you all for stopping by. I hope you all have a good rest of your day, and I'll see you next time. See ya.